We saw StrataShield was a very flashy solution, and they said they could control it, and they said that it was safe. We're going to show you an ingenious solution that is much simpler and will bring prosperity to more countries around the world.
Alright, so really quickly we're going to have you take a group survey to understand the general opinions towards climate change and some of the main issues we'll be talking about. So if you wouldn't mind going to kahoot.it on your phones or computers, and then there will be you'll enter the pin that's provided.
What's the pin?
It's gonna
It'll show you.
Here's the pin.
Sweet. They got a theme song.
Yeah. Composed by us.
My name.
Could be.
Wait, over there. That's not me.
Is that about everyone? I think that's it. So Josie's gonna compute the results, and we'll come back to your survey results in a bit.
This is so funny.
Question one, what you said.
What?
Sustainable cities.
Oh, shit.
Oh. Oh crap! I
was just like, okay, I'll let you
Wait.
It's like, this is like that hard, like, this is the most fun I've ever had.
You need to get out more. A lot more. You need to go to Jackpot TV too if you want even more fun.
Yes! That's what we were saying.
Here's the next question.
Jackpot
Alright.
TV.
Yeah, I know what's going on in the real world.
That's a leading question.
I take these What's the deal?
Relative to
Only
what?
2 answers.
Woohoo.
Okay, is our last question.
No, I think we should increase them. I'm all for war, disease, and pestilence. That'll solve our problems.
Cut down the population.
Alright, thank you for participating. We'll get back to your results in a minute.
Albedo is the reflectivity of a surface, and our solution is going to deal with increasing the reflectivity of the planetary albedo. It is a ratio of the radiation reflected and the radiation absorbed of a surface. Changes to the Earth albedo is a powerful driver of climate. So if we were to increase the albedo of the Earth, it would lead to a cooling effect because of the negative feedback cycle. Snow and ice are highly reflective, so they have a high albedo value, whereas rainforest has an albedo value of 0.1, and something like white concrete has an albedo value of close to 0.7.
So here's an annoying technical question. So albedo is strongly wavelengths dependent.
Mm-hmm.
And so in the real world, you want high albedos at the shortest incoming wavelengths. So what the albedo is in the red part of the spectrum, for instance, is not very relevant.
Mm-hmm.
What we care about is the blue part of the spectrum.
Mm-hmm. Whereas a color like white would still have shorter wavelengths. So forests, and especially rainforests, have a much lower albedo than open land. So deforestation could be a viable option to mitigating global warming due to reflectivity. Studies have shown that increasing global reflectivity can be more effective than reducing CO2 emissions and reducing global temperatures.
Okay, so this is a potential problem if you're trying to actually download this.
We can
skip it.
Yeah.
Well, this is a problem, is that you just have a wireless connection, you're trying to download something that's, I think, fairly big.
Yeah, it worked yesterday. That's good.
Okay, well, that would have given you a sense of what we're trying to implement, but nonetheless, our plan is based off of the city of Dubai, which is called the City of Gold in the United Arab Emirates, and it is known for being kind of a utopia of modern design.
Yeah, they got a snow ski run in a shopping
Who
center.
doesn't want that? You know what
That's
I
the
mean?
definition of utopia.
So our city will implement similar technological advances created with the intention of mitigating climate change by increasing surface reflectivity. Our plan will also improve public health issues in Latin America by eliminating vector-borne diseases and standing with indigenous farmers who are in the Amazon rainforest. Will take side with them in fighting for their rights and partnering with lumber companies and agricultural groups to gain support for this initiative. We'll scatter cities all throughout the northern region of Brazil here, which is a prime location for city building. And surrounding the cities, we'll introduce innovative agricultural modifications that don't simply soak up the sun the way outdated forests of yesteryear do, but rather increase albedo
Outdated
through
forests.
earth-shattering genetic modification sciences of agriculture. So, were you all convinced? Let's look at the results that we just calculated. We have sustainable cities, farmers' rights, eliminating vector-borne diseases. Everyone agrees that these are very important steps for creating a better world, and our group knows that increasing the albedo of the Earth is the only way to effectively slow climate change, and we're prepared to take the most extreme measures to save the planet.
So, as you can see here, the Amazon rainforest, located in red, is 2.14 million miles, and that has a terrible albedo of about 11 to 15%. And this is actually creating a feedback loop that is warming the Earth rather than cooling it. So, we propose
Paving it over.
the Amazon forest with our city called the Reflective City, based on the Dubai model. This is going to increase the albedo of the Earth, of this area to 70%. This will actually cool the entire planet by about 1 degree Celsius by 2050, we project. Go ahead. And this is also, oh, sorry, can you go back one? This is not only going to help cool the Earth, but this is also going to stimulate the international economy, boost the GDP of Brazil and other South American countries, and resolve many of the area's domestic conflicts. So specifically, we have the Amazon region has been plagued by a lot of bloody conflicts over human rights with indigenous farmers, industrial developers, the Brazilian government, loggers, that kind of thing. And so the Reflective City has the potential to actually eliminate these age-old conflicts and by appeasing all of these groups involved. So as you can see here, illegal logging has been a really big issue in this area for a very long time. And so we propose that by legalizing logging on a massive scale, we're going to eliminate the black market and actually regulate the industry a lot better and improve the GDP of Brazil. And then furthermore, we propose collaborating with Brazilian companies as well as international corporations to log on a massive scale, as well as implement agriculture in the surrounding areas to feed this large mega city. And so this is going to create the ultimate synergy of the world's best and brightest, and this will make Latin America's, or this area will become Latin America's Silicon Valley, and become a new hub of international power. So it will not only boost the GDP of Brazil, but it will also stimulate international growth and innovation.
All right, so you may be wondering what we're going to do with all this arable land that we now have due to the clear cutting that we've done. You also have this massive growing population, as Josie was saying, this new international hub of power, of technology, of advancement. So how are we going to feed all of these people, and what are we going to do with all the land surrounding it? So we are proposing in conjunction with the Dubai model, we are proposing regional crop modification. And what we're basically going to do is genetically modify crop leaf waxes, also known as the canopy structure. So we're going to increase the waxiness of these leaves of these particular agricultural crops. And what it's going to do is it's going to maximize surface reflectivity. They already have high albedos. They're also highly selective. So what studies have shown that certain crops, particularly maize, wheat, and barley, already have a high variability that produces a high amount of albedo in comparison to a lot of the other agricultural staple crops. So we're going to basically take those particular crops and genetically modify them. So we're just manipulating an already natural phenomenon. They also have regional and seasonal variants. So if you look at the world, there is a mid-latitude strip in northern or central North America, and then most of sort of northern Eurasia, and we'll show you a map later on. That is sort of this primary arable land region that we have at the moment. So we're going to implement this crop modification in that region as well as in the Amazon, because what you really need is arable land. And once we have implemented our clear-cut proposition, then we will have all this arable land so we can create and plant these biogenetically engineered crops. Great, and as you can see here, this is a maize field. It has 17 to 22% albedo, so if we plant it in roughly about half the region that we showed you on the map earlier of sort of the northern Amazon, it will help to mitigate the climate change. It also is incredibly cost effective, so the Dubai model, we recognize and understand that it is quite cost heavy, so it's going to cost a lot of money. So this is sort of our solution to sort of mitigate that. It's incredibly cost effective. It's also, these are agricultural crops, so primarily maize, wheat, and then in the Amazon region we're going to implement coffee as well, which is a big staple crop there. And these, the food that these crops produce will also help to feed the growing population of these urban sort of reflective cities that we are proposing to create.
And then this is just kind of breaking down our 8% increase. So we have kind of a two-pronged solution. In the first, this is the global crop modification. So it's going to be regionally specific. It's going to be picking the species that are most highly reflective naturally and then adding a 4% reflectivity. This was done by British scientists. They predicted that this modification would increase the albedo by about 4%. And this would include 19 million square miles of land. So 18.6 square miles of land are currently for agriculture. And that is including another million of the rainforest.
So this is a study. Somebody's actually done the integrated they've actually done that.
So they took it. It's from
Okay.
a sample, then they blew it up to a global
Be
scale.
interested in getting that. I personally don't believe this at all. We'll talk about that, but it's fine to
It
cite
was
it.
a peer-reviewed journal.
No, I understand.
Okay. And then in the second prong is the Dubai model, which will be implementing land use change throughout the Amazon region. So for this, it's using 1/9 the land that the first project is using, but it's incredibly more costly. However, there's going to be a delta albedo of about 60%, which is much more significant. And so this will at least increase planetary albedo by another 4%. So overall, it will be at least 8% increase. And then this is just a breakdown of that 8%, half of which will come from global crop modification, half of which will come from the Amazon land use change.
Alright, so our two-tier model of the leaf canopy method and the Dubai model have endless positive social impacts. The first of them, as I mentioned before, is indigenous rights. So there's a huge battle, as Josie talked about, of indigenous farmers working for their rights. With our help, they'll be able to gain the rights for their own land to implement farming and help sustain their own economy and boost Brazil become an economic hub. Also, eliminating the Amazon rainforest is one initiative that will help public health in all of Latin America. Yep, so mosquitoes of the Amazon carry malaria and yellow fever throughout the entire continent. Blood-sucking leeches and venomous snakes and frogs cause severe health concerns. Diseases such as cholera, hepatitis B, and other extreme conditions that thrive in the rainforest and its marshy habitats will be eliminated, and this threat will be gone, replaced with our reflective city.
What happens if the cure for cancer lives in the Amazon rainforest?
That will come with the reflective city. So here's the reflective city. So the extreme health dangers of the Amazon will be replaced, with this technology, improving the quality of life of our inhabitants and mitigating climate change through the reflectivity of both the plants and the city itself.
So now, why is to increasing the surface albedo is better than all the other engineering schemes that are currently available. And so to talk to the first would be an atmospheric shield. And so the atmospheric shield is likely the cheapest geoengineering scheme, but it's also the most temperamental. So its shield is likely composed of sulfur dioxide and would run the risk of interfering further with our already precarious climate system. And so it's difficult to determine how much, if any, would be safe. And even then, it would only be a temporary fix. So the shield would need to be continuously released, otherwise it would shock basically the climate back into predicted warming trajectories, and it would do so all at once. Now, at least with slower warming, we and the planet would have some time to adapt, but all at once would be undoubtedly catastrophic. So on top of all this, the shield wouldn't even correct abnormalities in rainfall. Acid rain would still be very prevalent, if not more, and the number of droughts and floods in various areas around the world would still be predicted to be as chaotic as climate change models already predict them to be. So we can thusly conclude that this plan would be far from ideal.
I like that one.
That was my favorite too.
I vote for this plan.
Could you hit the next one? Okay, and that brings us to our next geoengineering scheme, which is ocean modification. So our
Let's get rid of them too.
Oh, I got it. Our hydrosphere hangs in a delicate balance with our atmosphere. Ocean CO2 levels continuously attempt to come to equilibrium with atmospheric CO2 levels, slowly but inevitably. Now, when CO2 reacts with water, it forms carbonic acid, which is what makes your soda fizzy. Now, I don't know about you, but I've never seen any fish taken to swimming in soda, let alone any that I would eat, certainly. Now, increasing ocean acidification from both pollution and climate change have already irreversibly caused damage to our climate system. So marine populations have declined 50% in the last, between 1970 and 2012, less than 50 years. And that number is only seeking to increase. So, can you hit the next one?
Where'd that number come from?
But, strange. It's a GIF, but,
Oh,
essentially-
yeah, you'll have that problem if that's an animated GIF.
yeah.
Can't do anything about it.
Okay. So, can we really afford to tamper with our oceans anymore?
Yeah,
Except- I don't argue that.
we are on a daily basis.
Well, around 1 billion, actually over 1 billion people depend on fish as their primary animal protein source, with the vast majority of humanity depending on fish for at least part of their protein intake annually. Now, sabotaging this food source could spell a global food crisis, killing millions, if not billions, in the long run. All right, and now on to carbon sequestration. So carbon sequestration sounds like an easy fix. You're just taking the CO2 out of the atmosphere, right? In practice, a different story arises. Carbon capture and storage is likely the most expensive route thus far, and the field hasn't made any significant improvements in the last 10 years, in fact, even less than have been predicted. So it hasn't even had one commercial scale application for capture and storage yet. And so there have been multiple nations, including Norway, the UK, and the United States, which have canceled carbon capture and storage projects within the last 2 years alone. And this is due to high costs and technical issues that other projects have had so far. Now, one of the biggest issues of these technical issues revolves around the storage. Now, since the moment it's put in the ground and all the moments leading up to it, the geological feature which the CO2 is embedded in must be closely monitored, or else leaks or worse, blowouts are likely to occur. Now, these releases could result in warming, the exact warming that it sought to avoid, as well as poison people and ecosystems. Now, if you think this is rare, carbon capture and storage undeniably caused quakes in Algeria and blowouts in Mississippi, where they have now killed a significant amount of local wildlife. Now, if we need a nail in the coffin, carbon sequestration is simply economic inefficient. So it costs more than solar energy, costs more than wind energy, costs more than geothermal energy for each kilogram of CO2 avoided per unit of electricity generated. And so what that basically means is that it's more efficient to invest more into alternative energy than it is to invest into carbon sequestration, as of now and as is projected to happen in the next decade or so. So there are undoubtedly better ways to save the planet. And the last thing I would like to say is on surface reflectivity as to why our scheme is better than others. So we're already deforesting our planet at an incredible pace and industrializing.
So why not paint it at the same time?
Yep. Our approach would fall in line with the trajectory we humans have already set for ourselves, as well as protect our food sources, bring more money into the global economy, and prove itself sustainable in the long run.
Alright, so now you may be wondering, how are we going to implement these proposals? So, clear-cut, we are proposing to start immediately. Sooner the better, right, if we're trying to increase surface albedo by 8% by 2050. So we are proposing a 7 to 10 year project, starting from, we're going from east to west, so we're going to start at the ocean and move west. We're hoping to complete it by 2027, and that would be the complete clear cut of this entire northern Amazon region. And we're saying it's effective immediately. However, we're hoping that in the next 5 to 7 years or so, that we can start building our Dubai model and implementing that. We're also at the same time calling for a beginning now. We're going to start geoengineering our crop modification in the labs. The technology and advancement, the research that we have at the present moment can actually do this. Right now, it's already sort of in the early stages of process, so we're just saying we're going to speed it up. And we're hoping that that is going to be done by 2045, which we'll talk about later. Our Dubai model, we are hoping to implement starting somewhere in the next 5 to 7 years. And obviously this is going to be implemented as we sort of clear cut more and more of the region. We're going to sort of keep moving. And next one. And so we're going to begin our construction in 2025, and this is hopefully going to be on the east coast of Brazil, so right there on the Atlantic Ocean. And we're going to start with cool roofs, so like Delaney was saying, cool roof projects. We're going to paint the roofs white. Next one. We're going to do cement pavements, right? So sort of build this concrete city. Reflective exterior design, so like you saw in Dubai, they have sort of those reflective surfaces. And then we are hoping to complete it by 2050. And we have put into this an extra 3 to 4 years to address any sort of challenges that we may come up with. So we're ideally supposed to complete this entire thing by 2045, which will give us that, right about that 5-year window. And in Brazil, so we're going to talk about now the crop modifications. Like we said, we're geoengineering at the moment. We're hoping to begin in 2020, so we're going to, in the next three years, this can be done, and like we said, as we're clear cutting, we're going to sort of be implementing this more and more. So begin 2020, we're going to plant these crops, and hopefully complete it by 2050 as well. Again, we left a 5-year sort of window in there. Here's the map I was talking about a little bit earlier. As you can see, this mid-latitude region here, where the big red spots are, those are the best places of arable land in the world. So in addition to implementing our geoengineering crop modification in the Amazon region, we're also going to, effective in hopefully right around 2020, start planting them across this region here as well. So this is going to be sort of an ongoing project over the next 25 years or so. We're going to begin it in 2020. Obviously, we need to have a 20% increase per year in order to continue maintaining these high crop yields and the surface reflectivity. We're hoping it's going to be about a 25-year project, that's our prediction, which again leaves this 5-year window to address sort of any challenges or barriers that we might face. So just to give you sort of an overview, you can just keep moving through. Again, 2020, here we have increased crop modification by 2045. Up top, we've got our clear cut, our deforestation, and we've got into the reflecting city. So like Hunter said, we are proposing that this maximizing surface reflectivity by increasing the albedo of 8% of the world with this Dubai model that we're implementing to create this reflective city. Thank you very much.
What's the surface area of the city supposed to be? What are you projecting?
Half.